In this video, we're going to go through a couple examples of using for loops in MATLAB. So this first example that we're going to do is to write a function with the header line function f equals fact n that calculates the factorial of the input n. So the factorial of, say, 4 is going to be 4 times 3 times 2 times 1. The factorial of 7 is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. MATLAB already has a built-in factorial function. We're not going to use that in here, so I'm going to say that there's a rule. Sometimes your labs will have rules that says you cannot use built-in factorial function, because that kind of takes away the whole point. Even though MATLAB already has this function, we're going to rewrite it to help us go through for loops and learn kind of the basics behind coding for loops. So I'm going to start by writing function f equals fact n, my header line. And there's so many different ways to code this function. I recommend right now pausing the video and writing out kind of a plan of attack. Maybe you can write a flow chart or just write down kind of a pseudocode of what you think you might do. I'm also going to pause my video and write mine out real quick. I came up with for my kind of pseudocode, I'm going to start with an f, so that's that factorial equal to 1. We do have to define that before we can multiply that by anything. So before f can go to the right of an equal sign, we need to define f, which means it needs to be to the left of an equal sign. I'm then going to loop from I equals 2 to n. We could put 1 here. It's a little messy to do that, but because we're multiplying by 1 twice is not going to be a problem. And then each loop, I'm going to multiply f by I. So let's try this out. So I'm going to start with the f equals 1. So outside of my loop, I'm going to say that f is equal to 1. And then I'm going to loop. Here, I should just write this within my pseudocode here. So f equals 1. I'm going to loop from I equals 2 to n. So for I equals 2 to my input n. Each loop we're going to multiply f by I. So we're going to have a new f. F is equal to our old f, our previous f, times I. And then I'm going to have an end there. Let's save this. Saving it as fact, and let's put it in the right folder. And then going back to MATLAB, making sure I'm in the right folder here, I'm going to do the factorial of 5, which should be 5 times 4 times 3 times 2 times 1, which is 120, which is what I get. Let's kind of go through the code that we wrote and write out what happens each loop. So let's say our input is n equals 6. So the user inputs n equals 6. Then we have this line of code, f equals 1. So those values are defined first by the user, and then f is defined here, f equals 1. So when I am reading code or planning code, I sometimes like to just write everything out. So I'm going to make a little table, and I'm going to say I is going to be a column, and I'm going to write the values of I for each loop. So I could have first here, I have my loop number, and then my next column is going to be I. And the only other thing that's changing value inside that loop is f. So our values of I were going to be 2, 3, 4, 5, 6. So that's that 2 to n right there. So we have 1, 2, 3, 4, 5 loops. And let's look at F. So F, changing up my color here. So F is equal to, so each loop, F is equal to F, which right here, F is 1. So F is equal to 1 times I, right here, 2. So we get a new value of F being 2. In our second loop, no, I'll keep the same color. So our second loop, we have F is equal to F is now 2 times I, which is 3. So here we have 6. So next we have F is equal to 6 times 4. Next we have F is equal to the value of F, 24, times 5. Which is 120, which is what we got for the factorial of 5. But here we're doing the factorial of 6. So we have F is equal to 120, which is this, times 6, which is 720. That is our final value of F. A lot of times, students who haven't programmed before get kind of hung up on this F variable being on both sides. But essentially this is saying take the old value of F, multiply that by I, store that in F, and then we start again. So now we take that previous F, multiply it by I, store that in F, and we keep looping through again and again like we see in this table. You can see this is sequential, so we could also go another way. We could go 6, 5, 4, 3, 2, 1. And I'm just going to change up my code here to show you how we could do that. So we could start with F is equal to N. And then we could go for I equals N. Our step size here, because we're going down, we're going from N to N minus 1, N minus 2. Our step size is going to be -1. And we're going to stop at 1. And this should actually be N minus 1. So we're going to start at, if we're at 6, then we're going to multiply 6 by 5 first. So let's save this. And we get the same answer. So just like we created the table for the previous code, I recommend going through, reading this code, and setting up a very similar table to this one. So our first loop I is going to be 5, then 4, then 3, then 2, then 1, and you can calculate the value of F each loop. Okay, let's look at another example. So I'm going to do a new script. Here we're going to find the maximum value in a 1D array. So 1D array means we have either one column or one row. And we're going to find the maximum value. There is a function in MATLAB that does this for us. It's called max. But again, we are writing these functions that already exist within MATLAB to get some practice with our for loops. So we're going to have function m equals, let's call this my max of a, where a is a 1D array. So now we have to think, how do we know a value in an array is the maximum? If it's a short array, our brains can just look at it and say that's the highest. So if we have the array, let's say we have the array 1, 3, 4, and 1,000, we can look at that and our brains go, clearly it's 1,000. But unfortunately, our computers don't work that way. Our computers can only take comparisons between the numbers. So what we need to do in this mymax function is to compare, let's say, these two numbers. We can compare 1 and 3. Which one's higher? 3. So between our first two numbers, 3 is the maximum. And then we can compare 3 and 4. Between those two numbers, 3 is no longer our maximum, now it's 4. And then we get to this last comparison, and we compare 4 and 1,000, and we say which one's higher. Clearly it's 1,000. So 1,000 is our maximum. So we're going to start by saying maybe the first value is our maximum, because we don't know any better. Our maximum could be really any of these values. And then we're going to go through and compare side-by-side numbers and say, is 1 higher or is 3 higher? Is 3 higher or 4 higher? And so on. So let's go through and do that. So here we are going to be starting with m being, so we're going to set, that should have been a note. We're going to set m equal to the first value in A. So m is equal to A1. I'm just putting 1 index here because we know that this is a 1D array. Put my semicolon there. So m, the maximum, is equal to A1. Now we're going to cycle through. So we're going to say I'm going to pick an index. I really like to use I because it's easy to type. And then if I have a for loop inside my for loop, which we haven't seen yet, but we will, I would have a j, and so on. So I'm going to say for I equals, we don't need to start at 1 because, how do I want to do this? Yeah, we don't want to start at 1. Sorry, there are multiple ways to do this, and I want to make sure that I'm consistent as I'm coding. Sometimes it's hard to think through the code, verbalize the code, and code all at once. But we don't need to compare the first value to itself. So what I'm going to do, I'm going to start with 2, and I'm going to go to the last value of A. So one way that we can do that is we can use the length of A. Some of you coding might like to, instead of writing length of A here, you'll say here we have the length of A, and then you'll put N here. So it's really up to you. It's kind of a style difference, which one you like. The most common error I see with length is you're typing too fast and you spell it wrong. So just based on where the keys are located, the N, G, TH keys are all very close together. So that's a really, really common error that I see. And our brains work in a way that if all the letters are there and the first and the last letter are the same, our brains will read it correctly. So then we'll say, why isn't my code working? And it's because you made a little typo when you were spelling. So make sure that you take the time to kind of read it out and make sure that we spell that incorrectly. And hopefully, because I'm saying that now, we're not going to face that error, but I've definitely seen that error a lot with a lot of students. Okay, so we're going for I equals 2 to N. I sometimes like to write my end statement there and then just type inside here because I don't like my code being read. Okay, so for I equals 2 to N. So I want to compare M to the next value, which is A of I. If m is greater than a of I, so we're going to compare m to a of I. If m is greater than a of I, then m is still the max. So if we have 5 and then 1, we're going to compare 5 and 1. M is 5. After that comparison, 5 is greater than 1, so m should still be 5. If we have 5 and 7, m is 5. We compare 5 and 7. 7's higher, so we should replace m with 7. So let's type that out. So we're going to compare m to a of I. How do we make a comparison? We use an if statement. So I'm going to say if m is greater than a of I, then do nothing. So I'm going to show you another way that we can write this. Else, we want m, so else this means that a of I, it actually means it's greater than or equal to m. Then we have a new max. So our new max is a of I. We could also write this if statement here. So this is one way to do it. Another way to do it is just to do this part. So we don't even need that, you know, if m is greater than a of I, then do nothing. All we need to write is the when we need to do something. So let's work through what our function's doing here. And we're gonna work it out on paper here with an example. So let's say a is equal to 6, 2, 3, 7, 0, 10. It's a lot, but we'll do that. Okay, so what I'm going to do, we're going to loop. So first we have m is equal to 6. So that's this line of code right there. And then we have for I, here's our loop number. And the only thing that's changing value within our loop is m. So only thing to the left of an equal sign inside of our loop. So here we have 2 to the length of a. The length of a is 1, 2, 3, 4, 5, 6. So we have 2, 3, 4, 5, 6. Number of loops. 1, 2, 3, 4, 5. Okay, so our first loop, we come around here. I is equal to 2. Is a of I is, in this case, 2. I should have been more careful about that, but that's okay. So a of I is 2. So I'm just going to leave that note for me. Is 2 greater than or equal to 6? No. So I do nothing. So m is still equal to 6. Next loop. A of I is equal to 3. A of 3 is equal to 3. Is 3 greater than or equal to m, which is 6? No. So m is equal to 6. Next, I have a of 4. A of 4 is 7. Is 7 greater than or equal to 6? Yes. m is equal to 7. Next loop, 5. A of 5 is equal to 0. Is 0 greater than or equal to 7? No. M is equal to 7. Next, A of 6 is equal to 10. Is 10 greater than or equal to M? M is 7. Yes. M is now 10. Okay, let's go through and try running this in our command window. I should have saved it earlier. I'm not being a great role model for saving your codes, but you should save your codes frequently. I like living on the edge, I guess. Okay, so let's go here. We're gonna put in an array. And then we're gonna say max, or example max equals my max. It was all lowercase of A. And here I get 100. Which maybe you're saying, sure, 100, of course I could just look at this and say it's 100, so let's use this on a bigger matrix. Let's say B, and here I'm going to use the function rand to create a random number. So I'm going to use this format right here to create a maybe 1000 by 1 matrix. Rand creates random numbers or pseudo-random numbers between 0 and 1. And then we'll make a matrix of those. So let's try that out. B is equal to rand. We're going to use 1001. And put a semicolon here because it's going to be big. Looking at B, double clicking to look at it. We can see it's a bunch of random numbers between 0 and 1, or pseudo-random, I should say. So it's not perfectly random. So let's use my max of B. And the maximum here is 0.9995, which let's check this with MATLAB's max to make sure we're correct. And we are. So those were 2 examples using for loops. The second one also used an if statement. So if you had questions while we were going through them, please ask them in the comments below. Also know that this is not the only way to solve this problem. So if you came up with another way, that's great. You can even, if you came up with another way, you could comment the code below in the comments section on Canvas. I think that would be really helpful for others to see kind of how you might have gone about this if you came up with another method. If you have questions about this code or the other code, be sure to leave it in the comments. If you have questions about a specific line, you could say, I don't understand line 15, what's happening there? I just really encourage you to ask questions because the codes are going to progressively get more complicated. So I really want to make sure that we understand these 2 examples before moving on to more complex examples.